right, welcome everybody to today's session on Haystack at the NLP Summit. Yeah, super happy to be here today. I'm Malte Pietsch, CTO and co-founder of Deepset. And in the next 25 to 30 minutes, I want to show you what Haystack 2.0 is all about and how it can help you create AI applications in a more robust and also more enjoyable way. So my prompt for today's session is to give you a 360-degree overview of what Haystack is, and really have something in there for absolute beginners who maybe never heard about Haystack before, but also something for people who already used it or maybe have built applications with other orchestration frameworks out there. As we only have 30 minutes today, I will really try to keep it crisp, but I'm happy to answer questions in parallel in the chat, or you can also reach out afterwards privately to me for any follow-on. Our structure for the next 30 minutes is the following. We'll start a bit with context, where we come from, what's our background, and then really focus on basic concepts in Haystack 2.0, typical building patterns you should know, how Haystack can support you across the whole dev cycle, and then we'll basically conclude with a bit of an outlook into what's next, what's the future. So where do we come from? We started Deepset 6 years ago. That was really all before, I would say, the hype started. I remember we had to explain more or less every single time what NLP actually is, what it stands for. Back then there were, I would say, a few early attempts on transfer learning, but nothing really advanced, nothing really, I would say, standardized. We were working closely back then with NLP teams in the industry, really from day one, helping them to build NLP systems, build that together. So very close, I would say, to application side of it and really building things for production. And I think then one big moment for us was, so remember in 2018 when BERT came out, we were in the middle of one of these projects with Airbus, and we read the paper. We all felt this is huge. So we jumped on it, trained a custom BERT model for the industry back then trained a custom German BERT model, the very first BERT model, except from the Google team. We're early contributors then to Hugging Face transformers, worked a lot together with their team, and basically made our learnings how to build effectively with language models with transformers. We then pretty quickly realized that the model is really only one component in these systems that you need, and that developers spend a lot of time in writing the same glue code over and over again, especially for question answering and any retrieval-oriented use cases. And this made projects and development lab cycles pretty slow. So that realization then really led to launching our own open source project, Haystack, in 2020. That got heavily adopted pretty quickly. Netflix was one of the first big contributors. Things grew, thousands of companies started to build with Haystack, and it was really a cool time to see that growing. We again took then our learnings from all these users, from the community, from what people build, and launched our end-to-end enterprise platform, Deepset Cloud. And then fast forward with Gen AI hype in 2023, things evolved further and we all entered the Gen AI era. I would say building patterns changed slightly, new LM providers emerged, use cases also changed a bit, and Gen AI became really mainstream, really also accessible for a wider audience of developers. All of that we quickly incorporated them into Deepset Cloud, and also led us really to a complete rework of Haystack. And we released Haystack 2.0 in March this year. And this will be also the major focus for today, for this talk here. This way just hopefully gives you now a bit background. Where is this coming from? Why are we talking about Haystack 2.0? Here are some examples of people using our technology and products today. Really a mix of big tech, more classical industry players. We also have many startups using Haystack. Generally, I would say our community is a bit more enterprise heavy, a bit more geared towards that end. Okay, so much to the background. Let's now dive into Haystack 2.0. So what is Haystack? Haystack is an open source framework for building production-ready LLM applications. The most, say, typical use case that we see are around RAG, around agentic RAG, building some type of co-pilots, chat applications, or automating processes with some kind of information extraction. These, I would say, are really the typical ones, but as a framework, obviously people build all kinds of things. The key principles when we design and when we engineer Haystack are composability, transparency, and robustness. And you hear that today a bit more often across this talk because it really matters to us. That's really deep in our DNA, and that you will see when you use Haystack, when you look into the source code. This is our kind of North Star and principles for building. Haystack comes with a few key concepts and building blocks. It's not that many. It's really, we try to keep it minimal. And the two building blocks you should know are components and pipelines. These are the two main ones. Components are really small atomic units, small abstractions that do one job, and you can connect them in very flexible ways together, and that's what we call a pipeline. So why did we now do this huge rework? It was, I think, more than a year of work and launch now this new big 2.0 version. There are really three things that motivated us to do that and why we felt that it's actually necessary and valuable to do it. Number one, we really wanted to bring pipelines to a new level and make pipelines more powerful, more flexible for what you can use them. Mainly because we saw new building patterns emerging with LLMs. We had pipelines before, but with Gen AI, with LLMs, it became clear that these pipelines cannot stay linear. They cannot stay like directed as cyclic graphs that just go from A to basically to B to the end. Use cases are more diverse. They require looping, way more difficult branching. You want to self-correct if you have agentic use cases. So all of that needed a new approach to pipelines, and that's why I said, okay, let's do that. Let's build it out. The second thing we realized, and it's quite, I would say, independent of Gen AI and LLMs, is that customization is way more important than we initially also thought. It's basically in every use case that we saw at some point you need something custom, and you cannot have like a one size fits it all kind of template or pipeline structure that just fits to all these use cases. So we wanted to achieve two things. One, make it really easy, super simple to bring in your custom components, to code them and still use them within the structure of the framework. And second, we wanted to enable a more scalable system, a more structured system for integrations, for third-party integrations, to have a full ecosystem around Haystack, where it's very clear who provides it and what's basically the contract for these integrations. The third part that really was important in this redesign, we wanted to be even more explicit and transparent in what the framework does. This is I would say, a very conscious design decision, and it comes with advantages and disadvantages. From our experience, it's really helpful to not hide basically things that are happening in the framework, not abstract too much away from the user, but really make it explicit. Let the user know and let them make the conscious decision of, for example, how data flows between components in this pipeline, and really have only one job per component. So our abstractions are, I would say, quite minimal, very small, very transparent, very explicit. It also means we have more of them. So if you start building with Haystack, you realize, oh, there's actually a few more components that I need to put together. There are a few more connections that I need to make in these pipelines. This is basically why, because we want to make it explicit, and it really pays off in the, I would say, later stage of the development lifecycle. It's a steeper learning curve, I would say, in the very beginning for a very first demo, but it really pays off later when you start saying, oh, like I actually need to modify this data flow, or I actually want to just exchange this one component, then I think it's really really useful. Yeah, and our view on all of this, I think, is actually very much aligned with a recent article from Berkeley and on what they call compound AI systems. Their key claim is that more and more state-of-the-art results are obtained by AI systems and not single models. And this is really, I would say, a key trend this year, and I also think it will continue over the next years. They give some interesting points in the paper on why that is the case, why these compound AI systems are now so powerful, and why more and more people think of it when they build AI systems. Number one is really some tasks are easier and more efficient to improve via system design than via model training. You can bake a lot of things into a model training, but it's very hard then to iterate, very hard to make it work for all of these tasks. And so it's possible, but it's easier and more efficient to do it on the system level. The second thing, systems can be dynamic. So it's really not a one-time thing, but they can really change over time. And the third part is really about control and trust. These systems often make it more transparent what's actually happening. Looking into an LM, understanding what's the reasoning, why this and this happened, very hard to do. In a compound AI system, it's easier to point to a certain component and say, oh, like this is where this and this happened. This is where, I know, branching went into this direction, and make it more transparent for developers, but also for the end user. Well, and now that we say know about the high-level concept of a compound AI system, what does it really mean? Like, what is a compound AI system? The simplest one you can think of, and probably here already everyone knows by now about it, is a RAG pipeline. That's probably the simplest compound AI system. In Haystack concepts, you can build such a system now by assembling these 4 components here to a pipeline. You have the embedder that creates basically the vector from your query. You have then a retriever that uses that vector to look up, to retrieve documents, most similar documents from a vector database. And you can see here you have a number of third-party integrations that you can pick from and just use the technology, the vector database that you want to have in your stack. Once you retrieve the documents, you put that into a prompt builder. So this really assembles the prompt for your LLM. We use Ginger syntax here, so you can easily loop over the documents, adjust the info, get the information from certain fields. You can have multiple variables in your prompt. All of that is very flexible to adjust and customize. And then, you send the prompt to an LLM, to a generator. Again, you can pick from a variety here. Now, all that together, how does it look like in code? It's really about these 2 essential steps. You add your components to a pipeline. So all of those 4 components that you saw, you have to basically initialize and add to a pipeline. And then you draw connections. You basically here explicitly model the data flow from which component to what other component, who is the sender, who is the receiver. And if one of these components has multiple input options, you can also specify that easily and say, oh, for the prompt builder, this should go to the variable of documents. And then you can execute the pipeline, send a query, and again, define very explicitly where should your input data flow, to which component, to which input variable of your pipeline. Okay, so how now you can know the basic concepts. How can you now take it further? What are other typical building patterns to take this really to the next level and build more complex AI systems beyond the simple RAG example? Well, first of all, you need a way to easily bring in custom components. So in every use case, you sooner or later reach that point where you need something custom and where the standard RAG template doesn't really do it for you. Our opinion is like a framework should support you really in these cases, give you this flexibility, keep things simple, enable you to do that, rather than creating the need to rewrite your whole pipeline because the previous abstractions don't work anymore. And even though you just want to change a simple small step, you need to rewrite a lot of code. In Haystack, writing a custom component is as easy as this. It's a Python class. You have one run method and then a decorator for determining the output types of this component. That's it. And then you can use it right away in a pipeline in Haystack. So that's how you have a variety of components that you can pick from. How do you now assemble them into a real pipeline? What building patterns do you have there? First of all, branching. That's, I would say, a very common one, obvious one. You want to have different branches in your pipeline. Things should run in parallel. Common example is hybrid search, hybrid retrieval, where you get data basically from vector search, but also from BM25. And then afterwards, you join results from these two branches. Another one is routing, where again you have branches, but this time you pick based on a condition what to execute. So you say, oh, like if condition A, then go for this first branch, otherwise go for another branch. Also, that's very common, and we see that often as a building pattern in our pipelines. Last but not least, looping, also something that's very common. Some people call it agents or agentic pipelines now, where, for example, the system has a self-correction loop where it checks, okay, what's the reply? Is it good enough to return to the user, or do we want to go another round and maybe optimize this and get a better result? All right, so now you know what compound AI systems look like, what key concepts in Haystack allow you to build them. Big question, how is still, of course, why should I use a framework for all of this? Is this really needed? And there's been quite some threads in the last year online for what use cases frameworks are actually helpful or not. My point of view on this, it really depends on your use case and what kind of framework we talk about. To make this clear, if your use case is super simple, you just call one LLM, you prompt simply, that's it. You don't need a framework, in my opinion. For anything that goes more into the compound AI system, more into RAG use cases, I think there is a value in frameworks. On this framework level, I really believe a framework is only useful if it supports you across the full development lifecycle. And then it can be an extreme productivity booster, but only that. What doesn't work is having a framework that gets you to a first, impressive demo in 5 minutes, but then slows you down or makes things actually more complicated in the later steps of the dev cycle. For example, if things break in production, if you don't have the flexibility to customize your system, if convoluted abstractions make it really hard to debug and understand what's going on, if you don't find documentation, all of this, I would say, is not inherent to frameworks per se. This is just a bad framework, in my opinion. So let me quickly give you a few pointers how Haystack supports you across the whole dev cycle. We don't have time today to go into all these details, but slides will be shared. You can find links here. So think more about it as a 360 overview now across this dev cycle. In this first phase of building a prototype, the big challenges are you want to be fast, you want to really have coverage of different use cases, so you want to have the flexibility to build different use cases out, and things should be simple. You want to get started quickly, right? How Haystack as a framework supports you here is with templates. So we have a variety of recipes where you say, oh, like I want to have a chat application, I want to have a RAG application. These templates help you get started with an initial design. We have obviously a big ecosystem of integrations. You saw it on earlier slides. For many use cases, you can just say, oh, like I want to take this vector DB, I want to take this LLM, maybe this integration for source data that also accelerates you heavily in this initial prototyping. And last but not least, what we hear a lot from our community is documentation, and we invest heavily actually in that because I think it's fundamental to have really a useful product out there. You need good documentation. You need that things that are in there need to be working. So that's high importance to us. If you then continue and go into this phase of, oh yeah, I want to test this prototype further, I really want to optimize it, The two things or three things that you really want to know is how to evaluate, how can I measure, how can I then improve, like where can I go my next step, and then actually how to do that next step quickly, how can I navigate quickly to this next iteration of my pipeline design. And again, a few pointers here, how Haystack helps. We have an integrated evaluation module. We have third-party integrations for evaluation libraries to quickly get data, get metrics that inform you how good you are doing. And then we have a lot of debugging functionality, tracing functionality to understand more on an, say, individual level, on a sample level, okay, what is actually happening in this execution of my pipeline. Once you then know, okay, this is what I maybe want to do next, again, custom components and flexible pipeline logic enable you then to do that next step very quickly and rerun, for example, evaluation. Once you found your design, with that you want to go to production, again, I think a few resources here that really help you doing this. All of our pipelines are serializable, so very easy to go from Python code to something like YAML, move that to your target system, deploy it there, be it on Kubernetes. We have Hayhooks as a simple REST API layer on top, and things like Docker images and Helm charts. Last but not least, when you run production, things don't stop. Yeah, we of course also help you there when you're in operating mode, observing mode. We have tracing integrations with OpenTelemetry and Datadog, for example. We have a lot of things to optimize costs and efficiency, especially on the embedding side. There's a lot, I think, to reduce your costs when you're running production. And last but not least, a boring topic, but an important one, open source license management. They also really pay attention to what dependencies do we actually use in Haystack, what licenses do they have, are they compliant with, I would say, most common enterprise policies as well. So when we look at our community and a bit of user feedback, people who use Haystack, who started using it, who came from also from other communities, these I would say are the common themes that we hear. It's a lot about the way how we build our abstractions, that it's more intuitive, it's clearer, it's less convoluted, things work, and documentation is also often mentioned. We often get asked, okay, how are we positioned in this market? What is it really what Haystack is about? Here I can just emphasize again our design principles: composability, transparency, robustness. This is really, really important for us. This is where we come from. As Haystack has been around now for a couple of years, we have hundreds of production pipelines running really for years now in the community. And this, of course, also informs our say, development. So for us, it's important if we release a new thing, it must be robust. We cannot just deprecate things from one release to the other. We have deprecation policies in place. We will make sure that things are robust before we release something. This is, I think, where we are right now and where we come from. And then as any engineering team out there, any product team, you have to make trade-offs, right, in your choices, in your prioritization. There's always, I think, this trade-off between quality, speed, and quantity. And take this now with a grain of salt. It's obviously very subjective, but yeah, people often ask us how we think about these things. So if I would put us on this, say, trade-off, I think we are more on the if we prioritize basically robustness, quality, and the things that we build are often less, and sometimes we are slower, to be fair. But yeah, for us, it really matters that things work and that they make sense. So what's next? I think the future of AI systems will be that they solve more complex problems. They will do that by being more agentic, have more autonomy in planning out the execution of a graph, and they will consist of more components. That's pretty clear to me, and we see it actually already today evolving in our community. This is an example from a Haystack user, a GitHub issue that we had I think a couple of months ago, and probably one of the more complex pipelines that we saw. 32 components, more than 40 connections that this person created. It's very clear no one can fit this architecture anymore in their head. And also this user started then to visualize it, to draw it, to keep kind of overview of where he is and where he wants to go next. And this is, I think, happening more and more. And as a team, we also thought, okay, what can we do to support now these more complex AI compound systems? Because we think the dev approach necessarily has to become more assisted again in the future, more systematic and more automated. I think right now we're in this phase of we are just like, I don't know, optimizing this prompt, like hacking something together. I think this is not sustainable, and definitely not sustainable if we continue in the direction of more complex AI systems. So what we did is basically launching a new product called Deepset Studio. It's free for sign up. We launched it mid-August, and yeah, it's basically the idea to not have a low code, no code editor. Like it's definitely not replacing coding, but it should augment basically your coding experience in your IDE. So going between coding to, oh yeah, let me visualize this pipeline, going back. So it's really a two-way street. And it helps you basically to jumpstart your development process, but also when you enter debugging sessions, it can help actually to look, oh, this is what I have, and really augment your building experience. It's free, so here's a QR code. Feel free to sign up. It's really close to Haystack, so you will find all these components there. Give it a try. We also have here a quick video, quick demo, how that actually looks like. You see here on the left a big component library where you can pick components, put them on the canvas in the middle, edit here a prompt template, then draw connections. So this is really a Haystack pipeline as we saw it earlier. Yeah, this is really, you can take it for your initial phase for building a new pipeline, or you can just import whatever you have. So if you already coded something in Python, extract it, import it here into the library, visualize it, adjust it, change it, and when you're done, you can download it again on the top. It's all YAML back and forth, YAML visualization, very easy to go from one side to the other. Yeah, and with that, I'd like to conclude this session for today. Thank you for listening. I hope I got across like what Haystack, what compound AI systems are about. Would be cool if you if I got your interest. Try it out. Pip install Haystack -AI. And if you're also interested in the studio, would be cool if you sign up, give us feedback. We are in an early beta phase. So happy to hear any feedback from community, and it would really help us to bring this to the next level. Thank you.